A very good morning to everybody. I welcome you all for this session number 24. In this session, we will learn about virtual displacement and principle of virtual work. Let's recollect what we have studied in previous class. Degrees of freedom, which is defined as minimum number of independent variables or coordinates that are required to specify the system which are compatible with constraints. For a system of n particles moving freely in space, they can be represented by the position of a single point in 3n dimensional space, and it is called as configuration space of a system. The learning objective of this session is to understand virtual displacement, virtual work, and principle of virtual work. By the end of this session, we will understand what do you mean by virtual displacement, virtual work, and principle of virtual work. We know that when you apply a force, the body gets displaced. If the displacement is in the direction of the force component, then work is said to be done. Work is defined as the product of force component into displacement. Depending upon the angle theta, the work done can be positive or negative or zero. If the displacement and force they are in the same direction, then the work is positive. If the displacement and force are in opposite direction, work is said to be in negative. If angle theta is equal to 90 degree, then work is said to be 0. So work is defined as the product of force component acting along a displacement into that displacement. Now let us consider a system of forces acting on a body. If the body is under equilibrium, then the displacement is 0, then work done is 0. However, if we imagine if the displacement to be an infinitesimally small, then this infinitesimally imaginary displacement is assumed, and this displacement of the body is known as virtual displacement. Now look at this figure. You have along x-axis the time, and along y-axis you have position coordinates. For time t is equal to 0, the position is A. For time t is equal to 2, the position is B. However, for time t1, if imagine we have a particle hypothetically deviate very slightly from a given trajectory without violating the constraints, such displacement is known as virtual displacement. An imaginary, arbitrary, instantaneous change in the position of a particle of the system is known as virtual displacement. Note, virtual displacement is the displacement of the position coordinates only and does not involve variation in time. So students, imaginary, infinitesimally small displacement is assumed. Such displacement is known as virtual displacement. The work done by the forces on the body during virtual displacement is known as virtual work, which is represented by delta Wi, which is equal to summation I is equal to 1 to n Fi dot delta Ri. Now let us understand principle of virtual work. Let us consider a rigid body acted on by forces F1, F2 and F3 are the linear forces acting on a body which exhibits linear displacement. Likewise, let us assume moment couple M1, M2, M3 acting on a body which exhibits angular virtual displacement given by delta theta I. The work done by the linear forces is the sum of the force into their virtual displacement. The total virtual work due to linear forces is the summation of Fi dot delta Ri. Similarly, the total work done by the moment couple by angular displacement is given by summation of Mi delta theta I. So the total virtual work is the sum of the virtual work due to linear forces, virtual work due to moment couple. These total forces acting on a body gives a resultant displacement R. If the total displacement, which is R, is equal to 0, which is a condition for an equilibrium, then the total virtual work is 0. The total virtual work is 0 is known as principle of virtual work. So which states, if a body is in equilibrium, the total work of the external forces acting on a rigid body is 0 for any virtual displacement, or the total work done by the virtual displacement is 0, which is given by this expression. So in this session we learned what do you mean by virtual displacement, which is an imaginary, arbitrary, instantaneous change in the position vector of the particles of a system, and the work done by the virtual displacement is known as virtual work. And we also learned the principle of virtual work, which states a system of particles which is in equilibrium only if the total virtual work of the actual forces is 0. So now let's have a small MCQ session. Work done, question number 1. Work done by a force component acting on a system is negative when they are in force and displacement in opposite direction when theta is equal to 180 degree. Work done in pushing a wall is 0 because work is 0 when the angle between them is 90 degree. Virtual displacement is assumed. It is assumed to be an imaginary and infinitesimally small. So answer is both A and B. Virtual displacement is the displacement of only position and does not involve in time. Question number 5. Work done by the virtual displacement is always 0. Question number 6. Virtual linear displacement is represented by delta Ri. Virtual angular displacement is represented by delta theta I. We don't have here. So answer is none of the above. The total virtual work is the sum of linear virtual work and angular virtual work. So the answer is option A. Question number 9. The total virtual work is 0. This statement is principle of virtual work done. Question number 10. The condition for equilibrium is, so the resultant displacement should be 0. So the answer is 0. Hope you have enjoyed this session. Thank you all.